Okay, now we will do some numerical based on pH. For example, this is one of the question. Calculate the pH of 0.02 molar solution of HCl. Calculate the pH of 0.02 molar solution of HCl. Now, to determine pH, as you know, HCl, when you dissolve in water, it produces hydronium ion and Cl minus ion. And you know HCl is a strong acid, I mean it acts as strong electrolyte, and you know strong electrolyte, they undergo complete ionization. I mean, what is the concentration of HCl? It is given 0.02 molar. Concentration must be in molarity. Then you can use in pH equation. Since it is strong electrolyte and since it is 100% ionized, so the concentration of hydronium ion will be 0.02 molar. But if it is weak electrolyte, then the concentration of the acid is not equal to the concentration of hydronium ion, because weak electrolytes are partially ionized. So since it is strong, concentration of acid is equal to the concentration of ions. Now as you know, the pH formula, pH is equal minus log of concentration of hydronium ion. So minus log of, you can write, you put the value 0.02 molar. I mean you can write minus log of 2 into 10 to the power minus 2. That means you can write minus log of 2 plus minus log of 10 to the power minus 2, because log A into B, you can write log A plus log B, minus log 2. The log 2 value you can see in the table, it's 0.3010. This is the value of log 2. It should be minus, plus 10 to the power minus 2 means minus 2, minus minus become plus, I mean value will be 2. That means you will get the value 1.699, like this you will get the pH value. So this is the process how to determine the pH value for some acid or bases. Now another one, calculate the pH of 0.005 molar solution of sulfuric acid, suppose H2SO4. Now, as you know, sulfuric acid is also act as strong acid, H2SO4. When you dissolve in water, it produces hydronium ion and the sulfate ion. But here the equation is not balanced. To balance the equation, because you know sulfuric acid, its basicity is 2. I mean it releases 2 hydrogen. That is why it produces 2 hydronium ion. And here you have to put 2. Then the equation will be balanced. So you have to balance the equation. The concentration of sulfuric acid is given 0.005 molar. Since it is strong electrolyte, it also undergo complete ionization, and due to complete ionization, the concentration of the acid become equal to the concentration of the ions. But here, since 2 moles of hydronium ion present, that is why its concentration will be 2 into 0.005 molar. Because here 2 moles present, that's why the concentration become double. You have to multiply it by 2. If it is 3 moles, then you have to multiply it by 3. If it is 1 mole, then concentration of acid, concentration of ion will remain same. So 2 into 0.005 means you can write 0.01 molar. Okay. Now you can put the value minus log of concentration of 0.01. That means you can write minus log of 1 into 10 to the power minus 2. That means you can write minus log 1 plus minus log of 10 to the power minus 2. The value 10 to the power minus 2 become 2, and log 1 value is 0. So ultimately you will get the pH value as 2. So this is the process how to determine the pH value for different acid. Now I will give you a base how to determine the pH for base. For example, if the question is given like this, calculate calculate the concentration of hydronium ion, calculate the concentration of hydronium ion and OH minus ion and OH minus ion and the pH of 0.005 molar solution of sodium hydroxide. Suppose this is your question and you have to determine pH, concentration of hydronium ion, concentration of your OH minus ion. Now since it is a base, sodium hydroxide, so it's a basic solution. So how to determine the concentration of hydronium ion? As you know, sodium hydroxide, since it is a base, when you dissolve in water, it produces OH minus ion. I mean the ions will be Na plus N, OH minus ion. Here water will remain same here. And sodium hydroxide is one of the strong base. That is why if the concentration of sodium hydroxide is 0.005 molar, then the concentration of OH minus ion also will be 0.005 molar, because it is strong base completely ionized. That's why the concentration of base is equal to the concentration of the hydroxide ion. I mean you have got this question, one thing I have forgot to give in, calculate the pH of calculate the hydronium and OH minus ion and the pH of the solution of sodium hydroxide at 25 degrees Celsius. This should be given. Okay, therefore the concentration of hydronium ion, the concentration of OH minus ion is equal 0.005 molar. Now we know at 25 degrees Celsius concentration of hydronium ion into concentration of OH minus ion, this is equal 1 into 10 to the power minus 14. So therefore concentration of hydronium ion, you can write 10 to the power minus 14 divided by concentration of OH minus ion. I mean you can write 10 to the power minus 14 divided by 0.005. This is the concentration of hydroxide ion. Ultimately you will get this is 10 to the power minus 14 divided by this one, you can write 5 into 10 to the power minus 3. That means 1 by 5 into 10 to the power minus 11. So 1 by 5 means 0.2 into 10 to the power minus 11. That means you can write 2 into 10 to the power minus 12. This is the concentration of hydronium ion. So from the sodium hydroxide directly we have determined the concentration of hydroxide ion. If you know the concentration of hydroxide ion, you can determine concentration of hydronium ion also. So here concentration of hydronium ion is equal to 2 into 10 to the power minus 12. So we have determined concentration of hydronium ion, we have determined concentration of OH minus ion. Now we will determine the pH. Since we know the concentration of hydronium ion, so directly we can determine the pH. pH is equal minus log of concentration of hydronium ion. That means minus log of 2 into 10 to the power minus 12. That means you can write minus log of 2 plus minus log of 10 to the power minus 12. So log 2 value is 0.3010 and this will be 12, minus plus value will be 12. Ultimately you will get 11.69, this type of value. So since it's a basic solution, that's why pH must be more than 7. So if the substance is base, then you have to determine the pH in this way. Now I have given the numericals in which all the acid and bases are strong. That's why the concentration of the acid base equal to the concentration of ions. But if the acid or base is weak, then how to determine the concentration of the ions? So now I give you one question in which the acid or base will be weak electrolyte. For example, calculate the pH of 0.1 molar solution of acetic acid CH3COOH acetic acid if the degree of dissociation I mean alpha is 0.0132. So you have to determine the pH value for the weak electrolyte acetic acid. As you know, acetic acid is one of the example of weak acid. To do it, here degree of dissociation alpha is given. If you do not know the degree of dissociation, you cannot determine the pH for weak acid. So since it is weak acid, when you dissolve in water, it do not undergo complete ionization, so it produces hydronium ion and the acetate ion CH3CO minus. Here the concentration is given 0.01 molar, but if it is 0.01 molar, concentration of hydronium ion will not be equal to 0.1 molar because it is weak electrolyte. Weak electrolyte do not undergo 100% ionization. So that is why if the concentration of the acetic acid is C, initially concentration is 0. If at equilibrium alpha is the degree of dissociation, then it becomes C minus C alpha. This will be C alpha, this will be C alpha. Already you have got in Ostwald dilution law. I mean, here the concentration of hydronium ion is equal C into alpha. I mean concentration into degree of dissociation. In this way, you have to determine the concentration of hydronium ion. I mean, if the electrolyte is weak, I mean weak acid or weak base, then you should know about the degree of dissociation. Then you can find out the concentration of the ions. So here concentration is given 0.1 and degree of dissociation is given 0.0132. Ultimately you will get 0.00132. That means you can write 1.32 into 10 to the power minus 3. This is the concentration of hydronium ion. Now as you know, the pH is equal minus log of concentration of hydronium ion. So you put the value minus log of 1.32 into 10 to the power minus 3. That means minus log of 1.32 plus minus log of 10 to the power minus 3. Log of 1.32 value, it's minus 0.12 and log of 10 to the power minus 3, it become plus 3. So this become minus. So 3 minus 0.12, you will get 2.88. So in this way you can find out the pH value for weak electrolyte also. Always remember, if the acid or base is weak, then you should know about the degree of dissociation alpha. By doing C into alpha, I mean concentration into degree of dissociation, you can find out the concentration of the ions. So if you know the concentration of hydronium ion, then you can determine the pH value.